In this video, we are going to introduce time value of money. Generally speaking, we always say that $1 today is worth more than $1 tomorrow. So these calculations are based on that concept, and these terms are used in order to be able to establish the value of money, whether it's a future money or money in present day. So some basic definitions, the two key ones, present value and future value. Present value, the current value of future cash flows discounted at the appropriate discount rate. Meaning, or an example, if you are going to receive money in the future, how much would that money be worth today? Because the further away in the future you will receive that money, the less it's going to be worth today. A good example is when people win the lottery and they have the option to receive some money periodically for the next several years versus a lump sum today. So the lump sum is always a lower amount than the total if they would have gone through the years. However, just because it's lower doesn't mean that it's worth less. It's just that they got all of it now. Future value, think of it more as of an investment. If I invest this money today and I earn some kind of rate of return or interest rate, how much would I have in the future? The interest rate that I spoke about, whether you're investing or reducing the amount because you're looking at present value by certain rate, that's the one that goes into the formulas that we're going to use. Different ways to call this rate. You can call it interest rate. You may hear the term discount rate, cost of capital, opportunity cost of capital, opportunity cost by itself, required return. Which term they use will depend on the scenario and the context. Let's start with future values. I like to start with future value also because it's a little more intuitive. I put some money today in an investment. How much would I get in the future? Here are the letters that we typically use. Future value, present value, R for the interest rate, and T is the number of periods. Let's say if it's going to compound once a year, your investment, and it's going to be 5 years, then we have 5 periods. If it's a monthly compounding, then it's 12 times a year, and let's say it's also 5 years, then the number of periods will be the 12 times a year times the 5 years for a total of 60 periods. But those are the key letters that we're going to use for now. Let's take a moment to talk about compounding. There's simple interest and compound interest. Simple interest is interest earned only on the original principal, meaning that if you invest $100, you can earn interest on it, but on the next round, the next time interest is going to get paid, it's only going to get paid on the original $100, not the $100 and the previous interest. Compound interest is different in the sense that if you invest $100 and you earn some money on interest, it accumulates, and then the next round of interest payment will take the entire amount in consideration, the original principal, the previous interest earned, and then is going to pay you based on that, which results in a larger number. We'll see an example in a moment. Here's an example of compound interest. You have the $100 that you start with on year one, and it's a 10%. So you earn $10, 10% of $100, $110. Now, assuming that you did not deposit any more money and you did not withdraw any of the money, now you have $110 in your account. So on the next round of interest, you start with that 110. So now it's 10% of that. So now you have $11 of interest earned. You add that to original 110, now you're up to $121. So that's your starting point. So now you earn 10% of that. And so on for the next 5 years. The total interest accumulation is 6105, and the total amount in your account is 16105. If this was a simple interest scenario, what happens is that this $10 will always be the same, because you only will be earning 10% of the original 100. So this would have been $50 instead of 6105, and you would have ended up with $150. To put this example using the future value formula here, in this example, we're going to bring Excel. So it's 5 years, the $100 you started with, and the 10%. So using Excel as a calculator, we start with the equal sign to let Excel know that we're about to calculate something. We use a formula or a function, and the formula says present value. So I'm going to click there on the present value, B3, $100 there. So I'm going to multiply it using the asterisk for multiplication. Open the parenthesis, the 1 is standard, plus the rate, which is 10%. Close it, and I'm going to use an exponent. I got to use this symbol for the exponent. And in this case, it compounds once a year for 5 years. So 5 times 1, 5. Now notice how the formula gave me 161.05 cents. The advantage is that instead of me having to go one by one to find out what happens in 5 years, I can use the formula and go straight to the year I want. And gives me the total. Also, for example, let's say I wanted year 3. I wanted to know that number, year 3, without having to go through the step-by-step process. Then you could calculate it for 3 years, years 3. You see that 133.10? That's the same 133.10 we have here. So you can do it for any given year. So this is very useful if you're dealing with 30 years. Instead of doing 30 times the calculation like you saw on that table, I can write 30. It will know that that's the total at the end of the day. Once again, any year, amount of years, you can use it in the formula, and it tells you the amount that you will have total, the ending amount of that year. Now let's move on to present value. So the current value of future cash flows, as we mentioned, money in the future is going to be worth less than money today. Now, what kind of questions can you answer? What can you find out? The first one is a good example here. How much do I have to invest today to have some amount in the future? For example, people, when they plan for their retirement, they want to say, well, when I retire, I want to have this much money. So what you do then is you calculate how much do I have to invest now. So many years in the future, I have that amount. It could also be, I want to save for down payment on a house. So how much do I have to invest today? So a few years down the road, I have accumulated that money, which is better than just saving it, because you can earn some interest on it and grow it. Okay, so the second question, what is the current value of an amount to be received in the future? That's like the lottery question. If the lottery is going to be money in the future versus the lump sum today. Present value, why is it worth less? Inflation is the typical answer people give, which is true, that inflation is going to devalue money in the future, but that's not the only answer. The point is opportunity cost is another one. If I put my money here, then I cannot put it in other things. So I have to calculate also the other things that I could do with that money. Risk and uncertainty. We also like to calculate the potential risk of loss. So that becomes a risk issue. And you can go ahead and throw that in as part of your rate. Now, which rate you use, as mentioned before, it depends on the usage, depend what you're calculating it for. So the formula itself, we're familiar with the future value formula. All we're going to do is use algebra and rearrange to solve for present value. So you take this divided by that, and it leaves you present value by itself, and it looks like this. Future value divided by the discount rate. Let's go ahead and bring Excel back so we can do somewhat of an example. So that was the example previously, right? So let's say something similar, but let's change a few things here. We are going to now say, let's put it here, and let me bring the present value formula. We are going to work with that one now. So let's say when I retire in the future, I want to have $2 million. Let's also say that the interest rate I can earn on an investment that I make today is 10%. And let's say that I am 25 years old and I'm going to retire 40 years from now. And to keep it simple for now, we're going to assume that that 10%, it's annually compounding. So I want to know, if I just make one large deposit today, and that's it, and I don't deposit any more money over the next 40 years, how much can I put in now and never have to worry about depositing again, so it grows to 2 million at 10% over 40 years? So we follow the present value formula. So we take the future value divided by 1 plus the rate by the 40 years. So if I can put $44,189 now and some change and never touch it again, and never deposit or withdraw and just leave it there at 10% for 40 years, you would have $2 million in your account in 40 years from now for your retirement. Yes, retirement accounts are more complex because you put in payments, but that's something we're going to talk about a little further down the road. But this is an example of what you want to do. Let's do like the down payment for a house. Let's say I want to have $50,000 for down payment on a house, and about 5 years from now at 10%. I should have done this earlier. If you were to go to put in $31,000 and some change now at 10% in 5 years, you'll have the 50,000 without having to deposit any more money in the next 5 years. So these are lump sums and no deposits in between. Let's say you're a little more modest and just need 25,000 for your house down payment. Then if you put in 15,000 now, 500 and some change at 10%, 5 years, you will have $25,000. And that's the essence of present value and future value. You can calculate any of these letters in here by moving the formula around. For example, if you want to know the interest rate you need to earn to achieve certain goal. So This will be an example of if I need $25,000 5 years from now, and I have 15,523 now, and I need the 25,000 in 5 years, what interest rate would I need in order to achieve that goal? So I have 15,500 now. I need it to be 25,000 in 5 years. What interest rate do I need? If you calculate that, you'll get that 10% that we just used in the example. So you can always calculate for the missing item by moving the formula around. You can do the number of periods. Same example, you will use this formula. If I have $15,523 now, and I can earn 10% interest, and I want 25,000 in the future, how many years would it take me to get there? You calculate this way, and T will give you the 5 years. Now, I'll be honest. All of these that we did in these examples today we discussed can be done with a financial calculator that was required as material in the syllabus. There are videos online that I posted that you can use for tutorials on how to use a calculator for these functions. That's it for this video. See you on the next one.